Hello and welcome to this webinar today from Bruker Nanosurfaces, our stylus and optical metrology business. I'd like to speak with you today about our Contour 3D optical microscopes and what's new in Vision64. And I think some of you may wonder, okay, what is that? I'll go into a little bit of an introduction. I think this will be a fun and hopefully very informative presentation about the different new functionalities that come for our 3D optical microscopes. So first I'm going to introduce a little bit about Bruker, the stylus and optical metrology business unit, and the 3D microscopes themselves. And this other outline here shows you a little bit about what I'll do today. Before I go into the details of the presentation, I'd just like to highlight at the end of the discussion, we like to get your feedback in a very brief 5-question survey. The people that I've discussed with in the past that have done this survey say it takes less than 30 seconds or maybe 40 seconds to complete. And your feedback there is very valuable for us as we work to improve the content of our webinar series and bring content to you that you care to see. So if you could please do me the favor of filling that out at the end of the discussion, I'd really appreciate it. So now let's go into a little bit to the introduction. For those of you who do or do not know, this is a very concise overview of Bruker Nanosurfaces division. Bruker is a global analytical instruments company that has instrumentation ranging from nuclear magnetic resonance to X-ray fluorescence and Raman spectroscopy. And they also have, as part of their business, the Bruker Nanosurfaces division, which is a set of companies that produce scanning probe microscopy, 3D optical microscopes, stylus profilers, and also tribology and mechanical testers as a means of providing Bruker's users and customers capabilities in surface metrology and material identification and other wide array of functionality. So that's the Bruker Nanosurfaces division part of how we fit into Bruker. So the business unit that I work in here is, you see a picture there at the top, is a picture of the sunset here in Tucson, Arizona. This is the stylus and optical metrology business for Bruker. And this business really has been built on a history of both research and development and also QA, QC, and production surface metrology uses. We've got partners in hundreds of university and research labs, 1,000+ installed base in electronics and industrial manufacture. And over the world, we have over 10,000 instruments installed and working for the course of this business's history. You can see a picture of the building there in the bottom, and we like our home here in Tucson. The other things that we really try to do as we've gone into the early part of this next part of the 2000s is looking at Lean Six Sigma-based processes and how we can really ramp our manufacturing and be an excellent producer of systems for our users and customer partners. And then the last brief introduction is who are you listening to? This discussion is given as part of a free webinar series that we do within Bruker. And my name is Matt Novak. I've been here with Bruker for about 2.5 years doing applications development, engineering management for our metrology solutions. I've got about 17 years experience in optical engineering, fabrication, and metrology, and have my PhD work while working to develop capital metrology equipment. So I have a lot of different experiences, and I really value the chances I have to interact with the people such as yourselves that are listening to this discussion today and how we can make our products better and serve your needs better. And that's the goal for this webinar. So now, as you recall in the introduction, I mentioned that I would give a brief introduction to 3D optical microscopes. And this is just a picture of the 3 Contour type systems that we offer, our Contour family of products. They range from the lower right. The ContourGT is our best value metrology system, and this is really a very broad general purpose system which has minimal automation, but it can be scaled to be automated if the user chooses. It's ideal for a wide range of applications in industry or research. There's the lower left-hand corner, ContourGT system, which is really a focused, automated industrial benchtop system, can be used for production monitoring, has more automation and stage capabilities that are a part of our regular product line, and then ranging all the way up to our ContourGTX platform, which is a freestanding large platform system which is self-calibrating and can be run on a production floor. It can be run with a wafer handler in automation situations as well. And this is a range of 3D optical microscopes that provide a line of flexible, accurate, and fast metrology for our users. So what is a 3D microscope anyway? I know the audience intended here today, the majority of people will likely understand this already, but in case you want to have some background, I'd like to just explain in a very brief way a 3D microscope in the way that we see this adding to the value that people need from measurements. It's a special microscope with special objectives that are scanned perpendicular to a sample surface and process the reflected signal to produce an accurate height map. More specifically, in our case here at Bruker, we build systems that use coherent light interference to make that height map. You might hear this called a coherent scanning interferometer or a white light interferometer, a WLI system. There are different nomenclatures that people use. But in the picture that you see here, the elements of how the system works are outlined fairly clearly. On the left-hand side, you see there's some light sources, and then there's a set of optics that serve to bring that light to a beam splitter, which takes the beam down on through a microscope objective, that special microscope objective I mentioned, which you can see the name of it there. It's a Moreau type interference microscope objective. And then the light is reflected from the sample and the reference surface within that special objective back to the camera array up at the top of the image there. And by scanning through focus at the positions you want to measure, you can build up an extremely accurate vertical map as well as a two-dimensional picture of the surface. So I gave a pretty brief outline and introduction to Bruker and our stylus and optical metrology business, and then also a little bit about 3D microscopes. So now I want to spend the majority of the discussion time going over what Vision64 is and what is new with it. And really two key points. Vision64 is really the engine for Bruker's optical microscope systems, whether the Contour line, which I'm talking about here today, or we have the NP Flex line of tools. It's also the engine for our DECTAC stylus products where we do surface metrology. It's a very powerful software backup that is the kind of the integrating engine for our different surface metrology solutions. So I'll go into a little bit of those details, and then I'll describe the majority part of the discussion will be on some of the new and powerful features that are available within Vision64, so that people can get an idea of what we've been doing with the tools and how we're trying to streamline them and make them easier for you to use. So I wanted to spend just a minute about why is it important to have a very powerful engine such as Vision64 for a metrology equipment. I mean, really, this is a motivator for anybody who's doing a business where you're making in production some sort of different device that you need to control the process of manufacture, or if you're doing high-level research and study of different materials behaviors. There's all these elements come into play in terms of money that you spend to purchase equipment that you would use to make your work more valuable for yourself, the time that you spend researching such a purchase, and then also learning the tool itself and the training that you have to make the system work, which ultimately add to the productivity that you would expect to get from a piece of metrology equipment like this. And so for our discussion today, really, I'd like to focus on how Vision64 is really the heart of Bruker surface metrology solutions. This is a It's a very integrated, simplified user interface for our different metrology tools that streamlines the product use for whether you're a researcher or a production operator. The system is, this software system is really intuitive and easy to use, and I'll give some examples of that later. Really is meant to save operator time and ultimately improve the bottom line, and that's kind of what I would like you to try to keep in mind, is these different features that I'm going to talk about, how they could help you make a problem solution for the things that you're doing in your daily work. So this list is really just sort of a bullet list of different functionalities and capabilities that I'm going to go through that are new features that are available within Vision64, and some of them have to do, one has to do with the measuring mode called VXI, which we've recently introduced. I'm also going to cover examples of color imaging. We offer now color CCD imaging with our systems if users would like that. Different overlay and data display tools that we have made available to you. Cylindrical and automated stitching, as well as cylinder automation for rotating parts, and measuring at different locations in an automated fashion. Different data manipulation functionalities that we've enabled within Vision64, as well as very flexible automation setup that I'm going to go into some examples on how, and you'll see a few videos later that show this flexibility within the automation setup. And then last, a brief introduction of the integrated support for our 1000x imaging, which is our NanoLens AFM. These are all new capabilities that have been integrated within Vision64 and our 3D microscopes, and I'm going to go through them one by one now. So many people are familiar with white light scanning interferometers or coherence scanning interferometers. These types of systems make images based on interference, as I mentioned in the introduction to the different 3D optical microscope discussion. What Vision64 now enables, and this is a very new, recently released option for our products, is a VXI mode, which is our universal measurement mode for any different type of surface to optimize the signal from that surface. Traditionally, these kinds of systems make a vertical scan either by scanning a piezo or a stepper motor, and you can make a very accurate image, such as you see on the right-hand side. This is a surface with a scratch, and it has about 20 nanometers RA. This image is not a bad image by any stretch. It's just showing some of the features that you might see due to noise or different things coming into the image that you see. And with VXI, you actually get to make use of the complete optical signal in an automated way. The system will self-sense the smooth or rough nature of the surface like this, and it will use an improved center of mass algorithm to actually reproduce the data in a much more striking way, as you can see in this image. So a lot of those noise spikes that you might have seen previously are eliminated. This reduces artifacts that you might see on rougher edges and really helps to produce the highest quality data on some smooth surfaces as well as stepped or rough surfaces. These are, we feel, a very big enhancement, and it really has a strength to it that it requires no intervention from an operator in terms of parameters to set up. It's just a simple checkbox for setting up the type of mode scanning that you would like, and then the scan lengths that you would need to make an image. So this is a very powerful addition that's new in Vision64 for our 3D microscopes. I'd like to spend a little bit of time. I mentioned that we now are offering color CCDs, and some people may or may not find value in that, but we really felt that it's an advantage to people to be able to make both excellent 3D optical images with high accuracy in the vertical plane. And this example that you see here is a sort of a monochrome standard false color palette that you would see on many different 3D microscope systems. But we felt that there are some applications and examples where you may want to see more detail or understand more about what you're looking at. In this case, this is a wire bond imprint on a bond pad, where having a true color image actually makes quite a difference. And this kind of imaging is something that we've thought is a very powerful addition for being able to offer a standard color CCD and allowing for auto optimization of images like this. This is a strong contrast to just looking at a false color image and enhancing the true color with this 3DI overlay now. You can see very clearly a lot of the details about the aluminum and the passivated metals and the intermetallic compound that you see in the bond imprint for this example. And I'll spend a little bit of time talking about how this might be useful as a later application example in the discussion. So one of the key things to realize about this, we've made this a plug-and-play option for people that have the chance to use our Contour systems now. If you purchase a color camera as an aftermarket device, you can simply install it. It's a very easy installation, and then when you plug in the color camera, you automatically are able to set now the color balance, the white balancing that you need, and these user toggles will automatically show up in the Vision interface when you've done that with the color CCD implementation. And you can toggle between the default factory settings on the camera, or you can also set auto set the color balance for an application that's specific to a certain type of samples, for example, so that you get an optimum color image in just the push of a button. So we've really tried to make this an easy and streamlined implementation of color imaging for our users. It combines really still our highest accuracy 3D metrology and then true color images. And one thing I want to make clear is that we do this still with interferometric objectives, those same type of Moreau objectives that I showed in the very beginning introduction to the discussion. So there's not a need to switch to a bright field objective or a separate illuminator. This is just making use of the Contour system as it stands, giving the user the option to do 3D color interactive display, and you can go between the false color palette to this true color overlay and showing the two-dimensional traces on that color data for a display of the height data. So really the key takeaway is we're providing the same vertical resolution and accuracy metrology, but with tremendously improved visual imaging. I'd like to spend a little bit of time talking about different data display and features, some of the plot views that Vision64 now has enabled. This is a standard contour plot, which is, you can see the upper left icon is a little highlighted there for under data analysis. But if you click on this tool that's shown by the arrow here, control and left click, you can actually add a critical dimension analysis as well. These are very simple insert and remove plots from a view capability that Vision now offers to give enhanced features. One thing to note, this critical dimension plot, once you've actually inserted it, is now also a live analysis, so you can come here and make different use of the critical dimensioning tools. And once you've finished with that, you can control click again if you'd like to remove it to come back to this view, and then maybe you want to put a three-dimensional view. You can do that again very easily with control click, and now you can see an overlay of a three-dimensional view. So this is really a very nice functionality within Vision to show multiple analyses. It's a quick and easy way to do that. Spend a little bit of time talking about the critical dimensioning tool. This really is a flexible way of dimensioning different part geometries. You can actually add angle lines, datums you can put in to your measurement data. You can zoom in on both the measurement data, or you can insert nominal data as well and make comparisons or computations for parallelism or coplanarity, the radial concentricity, these types of things, or perpendicularity. These are all features that are implemented within this new critical dimensioning tool as a powerful way of displaying data and making comparisons to metrology that you need for your parts. And then as a word about that in terms of actually creating a report from these data, we've implemented a very simple, streamlined method for capturing any of the analysis windows or observation windows into the computer's internal memory. You can also save this type of information as a different resolution bitmap all the way up to 900 dpi to add it into an overall report in a very simple way. So we've made this as simple as possible to output different values that are of interest and make a reporting of the information that is of use. Another of the list of different items that I mentioned is now available with some of the new functionality within Vision64 is we've added cylinder stitching and also phi automation or rotary axis automation for flexibility for a different range of applications. And really, as an overview, really just make sure that it's clear this is available on our contour tools. If you there's an additional horizontal sample roller stage that you can add as an option to the systems. Or it's also available as part of our NP Flex products, which is the picture on the right. You see our large sample platform with rotary stage capability. And I've shown on the left-hand side a schematic that shows a combination of linear and rotational stage movements to provide measurements at different sites on a cylinder. And the steps are very easy. You take one measurement and then make a linear movement, take a next measurement, then make a rotary stage movement combined with a return of the linear stage to the first location. And step number 4, you take the next stage, the next image of the stage. You would make another linear stage movement, and you could then take the next image and rotate again, on, and you can go ahead and make an automation of measurement of a shaft surface like this at prescribed values of phi. Alternatively, you can support a complete cylinder stitch and unwrap to look at the wear of a radial lip seal, for example, which is shown on the right-hand side. So one of the other things that we've done is we've added within Vision the ability to do a very flexible support of external programs within automation. So when you've completed doing an automation within Vision, you can actually call to an external executable program that you have written yourself or you've purchased from a third party to make manipulation of the data and then return that information in a very seamless way. And this is a very powerful, flexible capability that is I want to introduce briefly now because I want to use that as one of the examples that I give for application use later. And just as a note, I thought I better mention, I don't know whether it's clear, but during the discussion, as I'm going through these different pieces of material, please type your questions into the questions box, and at the end of the discussion, I will we'll have time to go through and answer the questions. Any of the questions that I can't get to today, I will try to follow up directly after the presentation to close off on any questions that you might have. So please, as we go along, feel free to type in your questions, and I will answer them either at the end of the presentation or after the discussion is over today. So a next capability and new functionality from Vision64 that I'd like to talk about is I want to give a high-level overview of the automation functionality that's been introduced, because there are some really new, intuitive, and powerful capabilities that we're making available for our systems. One of the things that we've done is we've simplified into 3 basic, and 4 if you have rotary stages, but for the majority of people that have linear staging, 3 basic types of automation with very simple and easy to use graphical user interface setup. You can see the first one is XY scatter, and that's this first bullet where you have measurement locations randomly around on the stage if you had several different parts that you had irregular shapes or different geometries and you needed to put them on the stage and check the roughness or another feature, a step height on them. You could do this. You can have XY grid where you have a known spacing with different perfect rows and columns, and you can make the measurement at each different location and generally would set this up at the center of these locations. Or you can also do what we call a multi-grid setup, which is where you have some similar measurements that are repeated at many locations on the stage, or you may have different measurements altogether in these different subregions on the stage. So these are really simple, straightforward ways of setting up automation that I will go into a little bit more detail in the next few slides. As an example of this flexibility, I'm going to spend some time talking about our multi-grid, that last or third method for setting up multiple grid automation. And so the example you see here is a wafer. This can also be used to support multiple measurements on a tray if you had a tray of parts, or if you had multiple measurements you wanted to do per wafer die location. And really the key thing is that it's very simple and fast to set up, and I'm going to go into a little bit more detail about that in this slide and the next. I have a small video that shows this. But really the basic thing to keep in mind is that you can, at each measurement location you care about, set up subregions of different sizes as you see here, and then different measurement and alignment points. So to illustrate how easy it is to do this kind of a setup, I'm going to go ahead and show you a screen capture video where I do make such a setup. And I'm going to start that now, and hopefully you can see the yellow outline cursor. What you'll see is you see the display of Vision here, the live video. You see the three operational tabs, the instrument, analyze, and preference tabs. It's a very intuitive interface. And what I'd like for you to focus on is once you've gone through this kind of workflow where you see the measurement set up, you can see how Vision will easily allow for you to set your scan parameters and the different things that you want about the length of scan, and then the live video and the instrument control. But I'd like also to show you now how easy it is to set up a multi-grid automation. So you use the automation setup, which you see highlighted now. And in the recipe, you can choose multi-grid. There's a simple GUI that will allow you to select the multi-grid setup. And here you can see the setup recipe. It has 4 tabs, and what I'm showing now is how you can set a 10-inch by 10-inch substrate. The units are displayed there. You can change to millimeters, nanometers, different things. Now you can see a setting of grid. I'm going to go ahead and set 10 grid points that are 1 inch and apply these settings. And you can see the subregions added here, 10 by 10. Very straightforward, easy to set up. So now what if I want to add measurement locations? Well, it's a very intuitive thing. You just click the zoom. You can say you want to add a measurement at a different cell site. Click on the zoom and you'll be able to go ahead and zoom in on the cell and see how easy it is to add the alignments and measurement points when you do that. So what you're seeing now is a zoomed view of a particular cell where you can then add alignment points which are specific to that measurement cell. Those are done by setting this toggle and just clicking in the measurement area. You can do this by looking for patterns. Those are image files that are saved in a file to look for a match to a prescribed pattern, and you can spiral search at each of these alignment locations to make the alignment work. And then when you're ready, you can set measurement locations in much the same way. You can place them scattered in this manner. You can load them from a file. That's what that import button is. You can do this in a very straightforward way and then zoom back out to the overall substrate and multiple grid. Now you see we've set our measurement for one location, and you can do the same thing at another site. And the interesting thing is this can be totally different from the initial site where you have different alignment points and different location for measurement, which I'm showing in this example. But you can also copy the initial cell and paste it by using the functions that are shown on the left-hand side of the automation recipe editor. You can see very easily how quickly it is achieved to set up such an automation in multi-grid. So during that discussion, I talked about a little bit about using patterns, and I want to say a little bit more about what I mean there. What we've done is we've integrated within Vision64 the ability to do pattern finding. And so we offer a third-party add-on software, Cognex, which is a very ubiquitous software, and we use it to recognize patterns. You can teach and train the patterns within Vision. You can teach a recipe that is a magnification and scan speed and image type that you use to actually do the pattern finding. And then you can see an example of a pattern here, this green outlined shape, which I'd like you to keep in your mind because I'm going to show another brief video that shows the actual use. Now that I've shown you a video showing how you could set up multi-grid and talked a little bit about patterns, I will show you a video here in a moment that gives you a chance to see how this works in operation on a system. But the pattern finding is, there's a recipe editor for that, which you see on the left-hand side of the screen. You can define the pattern and set up an image capture, which would give you an image like this one. You can then define the recipe within Vision that does that imaging, capture an image, and then define this pattern and train it. This is a trained pattern that's being viewed. You can set the matching score that you care about. And if you notice, there are some checkboxes here. You can prompt an operator for manual alignment if the pattern match happens to fail, if there's some debris or a misalignment, or the spiral scan that you set, this second checkbox, is too small to find the pattern. If the misalignment is too big, you can do this in an operator way. You can do the full measurement. You can center the pattern in the field of view after matching. And this is a really powerful functionality. It allows for truly hands-off operation in conjunction with a robot loader, a wafer loader, or other people have integrated our systems with a robot parts handler to do this kind of multiple operation steps without operator intervention. So now that I've talked a little bit about the multi-grid automation capability, and I showed you how easy it is to set up. I did it on a simulation on my laptop computer, but I wanted people to see how easy it is actually to make use of it in practice and what that functionality looks like. So I made a simple video that I'm going to play now, and I'll narrate through what you're seeing when I play this. So looking at our ContourX platform with a wafer loaded onto a wafer vacuum chuck, and there are several different die on this wafer, different electronic devices on the sample itself. And what I'm doing now is running an automation. You can see the video at the left, that first pattern. You're doing an alignment at one point, which is in the center, and finding the pattern. It's making a measurement, and then you'll see it shift that pattern to the center for alignment. Now we're going to a second measurement grid location. You can see there are two alignment points. So we're making two measurements to do two alignments. They happen to be pretty well aligned in that case, so there was no obvious motion. Now we're moving to another pattern that's identical, another measurement location that's identical. You saw a slight shift and alignment there. That's the second alignment point. And now this is showing the last measurement location with two separate alignment points, and you can see the system is able to switch between magnifications and make an image and then center that last pattern. And now your measurements can be done at different magnifications. So this is a very flexible and powerful functionality. So now that the measurements, the alignments have been done, you'll see the 3D measurements start populating on the right-hand side. You could be measuring for pad heights. These could be solder bumps, or you could be looking at these trace widths that you see. And all of the information that you get here on this wafer, you can, by doing these, first the alignments and then the measurements, you can log that information to a database and save for future use. So this is really a powerful and flexible functionality that we've brought to our users within Vision64. So what's another example of how you can bring together some of these different features that I've just described? Really one example where people are interested in maybe color imaging but also three-dimensional data is in the area of copper wire bonding. People have been using copper wire to do wire bonding in automotive or high power packaging for a pretty long time now. As gold has become more and more expensive, it's important to be able to save material costs. So copper is a very common way of making those bond connections now. And one of the things that people like to monitor is this formation of intermetallic compounds, the actual weld between copper and the aluminum bond pad. And some of the things that I've talked about that are useful for addressing that application are true color imaging with interferometric objectives that can give vertical height measurement data as well, doing automation, and then also the ability to run an external executable on color image data. These are things that they're flexibilities that in the past were not very easy to get with the offerings of 3D microscopes from many different manufacturers. So as an example of, or a kind of a synthesis of the different things that we just spoke through, you could see where making use of a multi-grid automation with different copper wire bond pad prepared for looking at this cavity imprint depth, which is one of the parameters of how hard has the ball bond been put down onto the pad and with how much ultrasonic energy. You might do damage under the pad if you push too hard or if you use too much force. So you might want to monitor the depth or the volume of that bond imprint, which is a very easy and straightforward operation for our 3D microscopes. But in addition, in a step 2, you might want to automatically save as a JPEG that color image that you see because you want to analyze something about the information that's available in that color image in a way that's not typically done with 3D optical microscopes. So you could then do step 3, which is running an auto executable after your automation run that calls a third party or a home written executable script to do, in this case I've shown how you can use this to look at the smooth versus rough area to check this intermetallic compound area as return value to Vision64. It's a functional return that can help you to make and log into a database the tracked value of this IMC formation, making use of a lot of different functionalities that are new and different in Vision that were not available to users of these systems in the past. I mentioned there briefly the database. Really, we've simplified our database setup. We have streamlined it so that you can use templates. These are some functions that were available in the past, but really made a simple GUI type drop-down menu which allows you to check the pass-fail criteria and set and select the different types of analyses that are of interest, and then save and use these different pass-fail criteria for logging. The passing and failing lines are highlighted. Failing lines can be highlighted red in the database. These are all new functionalities that are available within Vision that help to streamline and make the use of Vision64 and our 3D microscopes more straightforward for our users. And one of the last things that I want to quickly mention and just briefly cover is we've really spent a lot of time, as you recall from the introduction, Bruker nanosurfaces has a set of companies that have products across a range of expertise, including scanning probe microscopy or atomic force microscopy. And because we have a set of global experts within our business that are available for support and understanding of the utility of AFM, we decided to make an offering of a 1000x version of a NanoLens AFM on our optical profilers. This really integrates the highest resolution measurements that we felt would be an added complement to people using our 50x or 115x objectives to do inspection. It can enable some small structure metrology, looking at semiconductor wafer applications or MEMS or different lithography applications. But really, we felt this is a nice complement to getting past the diffraction limit in conjunction with VXI and our different Acuity XR enhanced resolution offerings, particularly for people that might want to do defect or contamination review on board on the microscope. This is a nice combined use. So what we've done is we've added the ability within Vision64 to support this NanoLens AFM. And so there's integrated optics of the lens AFM that allow for up to a 16x view of the sample and the cantilever at the same time, which is what you see on the right-hand side. You can integrate this within Vision, and then the approach, withdraw, and measurement operations are also controlled from within Vision via push button. So you can home the scanner of the AFM, you can do data acquisition and zoom within there as well, and then process these data immediately within Vision64. And the key benefit by doing it this way, as in relation to other suppliers who offer as a third-party solution an AFM lens offering, we've added the ability to have the full functionality and operable capability of Vision64 analyses directly on the data that come from the lens AFM. And this is, I think, a very powerful addition to our capabilities with the Vision64 and our Contour products by offering this NanoLens for our customers that are interested in very small-scale, high-resolution imaging. So the last part of the outline was to provide a summary, and I'll go ahead and do that now. I mean, during today's discussion, I provided an introduction to Bruker Nano surfaces and the SOM, or stylus and optical metrology business in particular. I spent a little bit of time talking about 3D microscopes and giving a brief introduction to what a 3D microscope is. And then the majority of the time I spent highlighting functionality and new capabilities that are offered in our Vision64 software, which is really the heart of the Bruker metrology systems, both stylus and optical. I think I gave some excellent examples of how these new functions can bring value to your use of these types of systems. And at this time, I can open it up for questions, and we will go ahead and look at our questions box to go from there. So one of the first questions is it possible to get a circular arc segment profile instead of a linear one? Yeah, so the way that you would achieve this, if you recall how I discussed the stage automation, in the stage automation, there's the ability to actually bring in a stage file. I highlighted that in one of the videos. You can pull in a list of coordinates that would provide that arc segment profile. And you can measure and then stitch those afterwards yourself if you'd like to stitch them, or if you wanted to just measure at single sites and make disparate measurements because you're checking different parameters that are of interest to you, like roughness or waviness of the surface, that's also possible. So to do this kind of I guess a segment profile is very readily possible. It just has to be done by you know the coordinates that you want to inspect, and then pull them in. The format for doing that is a simple X. It's basically XY format. You type a text file which has the dimensions of the area of interest. So if it's in millimeters, you have millimeter, millimeter, and then you follow that up by the XY pair locations that you want to put in to your stage for this arc profile that you'd be interested to measure. So a next question is, how long does it typically take? What is the typical time to get data like you showed for the different types of electronic measurements? So we have the time to getting different data depends a little bit on how accurately you want to have the data and what is of most importance to you. If you want to have the very best accuracy, I recommend using our VXI measurement mode and doing that in an automated way, which will give you the best resolution. If you have to do high-speed, high-throughput measurements, and you can sacrifice slightly in terms of vertical resolution, you couple in noise when you scan quickly. Our systems can scan as fast as 115 microns per second, so you can get a very fast image of a full field of view. So depending on the application, these are the kinds of things that you would do to try to speed the results or to get the best quality data for your application. We have another question about topography on a surface which is created by thin transparent film. So as many people are aware, with a microscope system that's based on white light interferometry, if you have transparent materials that are causing a film step with dissimilar materials, you definitely can, depending on the type of materials, see a difference in the phase that comes from those, and therefore you have an offset in the height of the data that you see. Now the good news is if you understand this, you can actually apply some of the correction of our we have the ability to apply a correction based on a template that you can create within the software. It's a template you can create with what an analysis called SureVision. And then the areas of different materials can be corrected for their dissimilar index and phase shift in order to appropriately report the height value of such a film. An alternative way to actually measure such a film would be to make use of the NanoLens AFM. You could easily use the NanoLens, or you could also easily use our stylus profilometry to make such a measurement. Films that are on the order of 10 nanometers, such as we're asked about in this question, you can measure with repeatability down to below 1 nanometer, sub 0.5 nanometers with the DECTAC stylus profiler. So that would be another way to address such a problem. Someone asks if the automations that I just showed are backwards compatible to other legacy systems. So the good news is a lot of these types of things are compatible. If you've purchased a system from Bruker in the last couple of years, these are available as a software upgrade that can be available for purchase. If your system's under warranty, you can get these capabilities added as a software upgrade under warranty. But yes, a lot of these functions are available as capabilities for prior or legacy users of the systems. Someone asks, what are some other examples of automation that you could provide? Can you provide cylinder stitching on multiple diameters? So I think I understand this question to mean if a surface that is of interest is, for example, maybe a shaft that has a machine surface that's a different diameter than the mounting surface, is how I'm going to interpret that. And if that is the case, then yes, we are able to make a measurement by mounting on either our horizontal sample rolling stage or on our rotary axis phi stage on one surface, and then input the measurement diameter for that surface on another surface as well. So that is a capability that is now available within Vision. Someone asks if while doing this automation, are there any restrictions on the analyses that can be performed? The way I interpret that is maybe can you stitch, or can you do other different types of analyses within the automation? And the answer is yes. So any of the automations can be used to set up stitching at multiple locations, reporting to the database of various location information such as roughness or the stage coordinates or a step height or waviness or other output of analyses such as volume or trench height or depth. All these different analyses that people are used to seeing from within Vision, these new automation capabilities only build from that. They actually enable a more flexible application of those analyses to different situations for your use. So there isn't a restriction on how you can actually report to the database or collect the information at these different sites. The automation is really just the brains behind how the system will gather the data that you want to analyze. And we've tried to make that as flexible and straightforward as possible. Another question is for the lens AFM, what is a good use for defect? Can you compare to other optical measurement methods the resolution you get for this kind of an AFM? So the lens AFM, the way this system works is it is an integrated, basically works just like a very high magnification objective on the turret. And that's how I like to think of it. It provides about 1000x magnification. Our typical 100x field of view with a 2x multiplier is around 25 microns square, whereas it is very easy to get 5 times zoom for the lens AFM down to a NanoLens field of view of 5 microns. So that would provide this 1000x nominal magnification. And the AFM itself has it's a very robust unit. It allows for 20 micron Z range. You can scan an area as large as 100 microns, and you can go down to almost stationary scans to look at the kind of noise floor you're getting from the lens AFM. So it's a pretty wide variety of applications where you can use it, and it really functions just like an extra turret objective with much higher magnification. And I guess a side note to that is Vision, when someone adds an optional NanoLens AFM, the Vision software becomes a warning system for that user. There's a cable that connects to the lens AFM. Vision allows for protective use of the system and warns the operator when the turret will move. So it builds in intelligence to allow a seamless integration of the NanoLens AFM next to other high magnification or other low magnification objectives on your turret. And I think here's another question on roughness. Can you comment on VXI and how it affects roughness measurements? So VXI, this VXI is a nice combined use of the surface spatial, the spatial frequency information in the surface as well as the roughness information, and some enhanced algorithms for giving the data on the vertical scale. So with this new implementation of vertical scanning, we feel we are providing PSI type resolution or phase shifting type resolution to vertical scans even on somewhat rough surfaces, and this allows us to produce the most accurate roughness information possible even for surfaces that have hundreds of nanometers or half micron type roughness. So we do recommend that using VXI in combination with the proper filtering and understanding of the areas of inspection interest, that one can achieve the best and most accurate roughness information possible from this type of a system. And I think there's another question. NanoLens is basically just allowing high lateral resolution, and the answer is yes. That is really how we like to think of it. Bruker, the BNS division, sells some very nice high accuracy, high performance atomic force microscopes that enable all the typical atomic force microscope capabilities that people are used to, including phase imaging or electrical property measurements, thermal property measurements. We consider more the focus on the NanoLens as a high lateral resolution capability that our combined new offering of Vision64 and our 3D microscope platforms allows people to have. So it looks like that's it for the questions, and I want to thank everyone for their time today, and appreciate if you could spend the last 30 seconds or 40 seconds to fill out the survey at the end of the presentation as you exit. And again, very much appreciate the time spent and hope this presentation was a valuable introduction to the new and different capabilities that Vision is bringing to our Contour 3D optical microscopes, and look forward to the next chance to present good information to you in our webinar series. Thank you very much.